Okay, so welcome back to another video. So here we have a geometry problem, and that is, here the construction is that we have the a quarter of a circle, and then inscribed of there is the full circle over here, and we have a tangent line that says the length from between this to this distance, well, chord specifically, is 12. And so the question is, what is the shaded area? So specifically, what is the area that is in orange? So this is actually not as bad as you think it is, since the construction relies on that we can actually put in a triangle. So we can actually construct a couple line segments and then use that idea that with some of the measurements, including with the circle included, we use like the definition with the radius as well. Then we can actually utilize that fact that we can, once we find our distance, so we can take the area of the quarter circle and subtract with the area of the full inscribed circle to get what we want to achieve. So since I already have this out, so what I'm going to do now is I'm actually just going to draw the same thing at a smaller scale, but of course not drawn to be scale exactly, and then we'll follow the constructions from there before we actually, calculate the area itself. Okay, so here I just draw the same construction just like before, and so this is supposed to be with 12, and let me actually label our little vertices over here. So we'll call this A, I'll call this B, C, D, and then E right here. So now let's suppose that the radius of our quarter circle, we'll call this R. So this is R. And then we'll call the radius of the full inscribed circle, so we'll just call this lowercase m. So now what I can do is we can actually construct a triangle over here. So what I'll do is I'll draw a line segment from B to vertices B and D. So let me see if I can get this right. Okay, so here's the construction of line segment B and D. And so we notice that this forms a right angle over here, and I guess I should have put that earlier as well, the construction. So we notice that the height from line segment ED is actually just double the height of the radius of the full inscribed circle, so I'll just call this length 2m from E to D. Then we can make some observations that line segment BD is simply just equal to, BD is just equal to R, since that's actually like the whole definition of like radius, since this is the quarter circle over here. Okay, and then we also notice that line segment DE is actually just 2 times m. M is our radius for the smaller circle. So with that, now let's actually note some things. Triangle BD, BDE, that's a right angle triangle with, with the right angle being inscribed at vertices E. Then we can actually just apply Pythagorean theorem. So we would have that the legs is BE and BD. So yeah, so with the hypotenuse BD and the legs BE and ED, so here BD square is equal to, so BE line segment square, add this with ED, or I guess rather for notation purposes, for alphabetically speaking, we say DE is DE square. Okay, then from there we can actually just substitute our lengths. So BD is supposed to be R, so we have R square. Set this equal to length BE, so that's 144. 12 times 12. And then multiply, or add this with 2m squared, so plus 4m squared. Now, if we actually do a little bit of algebra and get m squared by itself, well, you'll see what happens why we want m squared by itself eventually. So that would mean that I just have to subtract 144 and divide 4 to both sides. So that means m squared is equal to, R squared, subtract 144, then divided by 4. So the whole point of this video is we want to find the area, so whatever's like you see the orange lines. So we notice that we actually, to do so, we would actually take the area of the quarter circle and then subtract that with the area of the full inscribed circle. So we know how to calculate areas of circles. So basically the quarter circle is just pi r square, then divided by that by 4. So let me say shaded area for, to be a little specific here. So that would mean that this is equal to pi squared divided by, pi r square, then divided by 4. And then we subtract that with pi times m squared, since that's the area of this circle right here. So looky, we have an m squared that we just showed here. So why don't we actually just substitute this back in? And then pretty much that's actually, we're done here because the simplification is actually very simple than you'd think. So pi r squared divided by 4, and then subtract by pi multiplied by here, so distribute, so it's pi r squared minus 144, then divided by 4. Then we notice that it's pi r squared minus pi r squared. Add this one, 144 divided by 4. Then the pi r squares cancel each other out. So it's just equal to, that's supposed to be pi right here. Okay, and then, so we have 144 pi, then divided by 4, but that actually just simply comes down to 36 pi, which actually is just the final answer to our shaded area, like so. So this is actually one of those geometry problems where you have to rely on adding additional constructions to, the given. So like what we did is, we added more line segments, and we actually give a few labels just to see like what we can use for like rules and identities we could use to actually, achieve the goal of what we're supposed to do, just like that. So yeah, that's pretty cool if you ask me.